Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem without a calculator. So we have 5 to the power of 5 times 4 to the power of 7. So what I'm first going to do is I'm going to rewrite this as 5 to the power of 5 times 4 to the power of 5 plus 2. Now, an important property of logarithms is that if we have a to the power of m plus n, this is the same thing as a to the power of m times a to the power of n. So if we have 4 to the power of 5 plus 2, this is the same thing as 4 to the power of 5 times 4 to the power of 2. Because 5 in this case is m and 2 is n. And we're still multiplying this with 5 to the power of 5. Now, another property of logarithms is that if we have a to the power of n times b to the power of n, this is equal to a times b in parentheses to the power of n. So right here we have 5 to the power of 5 times 4 to the power of 5, and 5 in this case is n, and 5 and 4 are a and b respectively. So this can be converted to 5 times 4 to the power of 5 times 4 squared. Now 5 times 4 is 20, so now we have 20 to the power of 5 times 4 squared. Well, 4 is the same thing as 2 to the power of 2. So we have 2 to the power of 2 to the power of 2. So now we have 20 to the power of 5 times 2 to the power of 2 to the power of 2. Now, if we have something, now this is actually another exponential property, but if we have a to the power of m to the power of n, so if we have a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of 2, this is the same thing as 2 to the power of 4, because we're simply multiplying these two. And I'm going to rewrite 20 as 10 times 2. So we have 10 times 2 to the power of 5 times 2 to the power of 4. So now, remember, we're going to use this property, a to the power of n times b to the power of n equals a times b to the power of n, but we're simply reversing it. So we're going to convert this form back to this form. So a times b to the power of n, so 10 times 2 to the power of 5, this is the same thing as 10 to the power of 5 times 2 to the power of 5. And we're still multiplying this with 4. And now remember this property, when we're multiplying two exponents, we add our exponents. So 2 to the power of 5 times 2 to the power of 4, this is 2 to the power of 5 plus 2 to the power of 5 plus 4, which is 2 to the power of 9 times 10 to the power of 5. Now, 2 to the power of 9 is equal to 512. And 10 to the power of 5 is simply, when we're multiplying something with 10 to a specific power, we're simply adding the exponent amount of zeros to that number. So we're going to add 5 zeros to 512. So we have 1, 2, 3, 4, 5. So this here is our answer to this problem. Alright, so in this video, I'm going to solve the problem 15 to the power of 50 over 3 to the power of 25. So to solve this, I'm going to first start by rewriting this as 15 to the power of 25 plus 25. So we wrote 50 as 25 plus 25 over 3 to the power of 25. And the reason I did this is because now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So in this case, 15 to the power of 25 plus 25 is going to equal 15 to the power of 25 times 15 to the power of 25. And I have this over 3 to the power of 25. And now this is equal to 15 to the power of 25 times 15 to the power of 25 over 3 to the power of 25, which is equal to 15 to the power of 25 times 15 over 3 to the power of 25. And this is equal to 15 to the power of 25 times 5 to the power of 25. Now another property of exponents is that if I have something from a to the power of m times b to the power of m, this is equal to a times b to the power of m. So this is going to equal 15 times 5 to the power of 25, which is equal to 75 to the power of 25. So this is my answer.